Hi, geometry classes. This is lesson 10 in circles, arc length and area of sectors. So if we first need to just review circumference and area of a circle. So the circumference of a circle, there are two different formulas we can use. Circumference is either pi times d, and d is the diameter, or circumference is 2 pi r. Now normally I generally use this second formula because I'm given the radius, but either one is absolutely fine because you guys know that the diameter is just 2 times the radius anyway. So that's why these or both formulas work. The second formula is area of a circle. And there's just one formula for area of a circle. The area of a circle, you just need the radius, and the formula is pi r squared. So basically you're taking the radius, you're squaring it, and you're multiplying it by pi. Remember, for pi, we're always going to use the pi button on our calculator. You're not going to use 3.14. So this is something that you did previously back in middle school, and we worked on it a little bit this year as well. What we're going to do today is not find the area of the entire circle, but just find the area of like a piece of it. So if you're thinking of like a piece of pie, a pizza pie, and you have one slice, we're going to find the area of one slice of that pie. Okay, so one slice of the circle. Or I'm not going to find the circumference of the entire circle, but I'm going to find just a part of the length. Now we talked about the arcs as well, the measure of the arcs, and we did that in degrees, but now we're going to actually find the length, and that length might be in centimeters or inches or something like that. All right, so let's look at the first example. For a circle whose equation is x minus 2 squared plus y plus 5 squared equals 36, which of the following is closest to its area? So you guys know this is a standard form for the equation of a circle. The center are the numbers next to the x and the y, so the center is 2, negative 5. And the number on the right is the radius squared, so the radius is the square root of 36, which is 6. Now for this particular problem, I didn't need to know the center. I really just needed to know this radius. So area of a circle is pi r squared, pi times 6 squared. So that's 36 pi. And I do that in my calculator, and I get 113.09. All right, so closest to 113. So now let's take that, now that we've just practiced how to do the area of the entire circle, let's talk about finding the area of just a part of the circle. So how many degrees make up a full rotation of a circle? Like if I started here at point B and I went completely around the circle, all the way around back to point B again, okay, everybody should know at this point that that's 360 degrees. Okay, now I also want to find out the measure of angle ACB. Well, look at ACB right there. ACB is forming a straight line, so the measure of angle ACB is 180 degrees. All right, because it forms a line. It also happens to be half a circle, so that makes sense that it's also 180 degrees. What kind of angle is angle ACB? Well, it's a straight angle, but in terms of the circle, it's a central angle. And we remember that a central angle is equal to the arc. Okay, so if I'm talking about angle ACB, okay, the arc that it intercepts is this arc right here, and I'll highlight that in green, and that's half a circle. That would be 180 degrees. All right, next up I want to find the exact circumference of the circle. Well, circumference is 2 pi r. My radius is 5. That's on my picture right there. So 2 pi times 5, and that's 10 pi. Now notice the word exact. Exact means I'm going to leave pi in my answer. Well, pi is an irrational number. Once you put pi into your calculator, you no longer have an exact answer. What is the exact measure of the length of arc AB? Well, if the exact circumference of the entire circle is 10 pi, and arc AB, which I have in green right there, is half of a circle, half of 10 pi is 5 pi. So that's the exact measure of the length of AB. All right. What is a sector? Because we haven't really talked about that, and that's what we're going to find the area of sectors here. A sector is a portion of a circle that's bounded or surrounded by two radii and an arc. Sectors are amazingly important in design, engineering, mathematics, and pizza, as I mentioned before, since a slice of a circular pizza is almost always a sector. In today's lesson, we will work with how to find the area and arc length of a sector. So if I have a circle, okay, and there's my center, here's a radius, and here's a radius. So a sector is a portion of the circle that's surrounded by the two radii, right there, and the arc. So basically, you're talking about this little piece of the circle. So that's the sector, and I might find the area of that, or I might find the length of this arc right here, which I just did that up above. It was a little bit easier because I knew it was half a circle, so all I had to do is to find half of that circumference. Okay, but it's not always going to be half, so we're going to have to, let's see how we actually do it. So if you're looking, let's flip over to the next page. All right, example 2, circle O is shown below with a radius of 12, and a sector has been defined by two radii, OB and OA, with a central angle of 60 degrees as shown. This in geometry is known as a minor sector. Well, that makes sense because that's a minor arc. So why do you think it includes the word minor? Because it's less than 180 degrees. The angle is less than 180 degrees. Let's find the circumference and area of the entire circle. So circumference is 2 pi r. My radius is 12. So 2 times pi times 12 is 24 pi. Okay? If I was going to do that in my calculator, so first I'm going to do it in terms of pi. There's my answer. If I want to do it to the nearest hundredth, now that's 2 decimal places. So all you're going to do is you're going to put it into your calculator, 24 times pi. And that gives me 75.398. And I want it to the nearest hundredth. That's going to be 75.40. Okay, so that's my circumference. Area is pi r squared. So pi times 12 squared. Well, 12 squared is 144. So there's my area in terms of pi. Or to the nearest hundredth, I do 144 times pi in my calculator. And that gives me 452.39. So that's the area of the entire circle, and that's the circumference of the entire circle. Now, what portion of the fractions, circle's area and circumference are contained in the shaded sector? Well, I have 60 degrees out of 360 because a full circle is 360. So basically, if you were to reduce that, 1/6 of the circle is that shaded part. So if I wanted to find the length, okay, of just, I spelled length wrong, sorry about that. So if I want to find the length of arc AB, okay, that would be 1/6 of that entire circumference. So 1/6 times 24 pi is 4 pi. If I want to do that to the nearest hundredth, I'm going to do 4 times pi, 12.57. Okay, and the area of the sector, same thing. I'm going to do 1/6 times the entire area, which is 144 pi, and that gives me 24 pi. And if I wanted that to the nearest hundredth, that's 75.40. Okay, so that's just the area of that sector, or the length of arc AB. So all I'm doing is actually taking the area of the entire circle and you multiply it by the portion of the circle that you're talking about. All right, so the key to all this sector work is the fraction of the circle that has been taken up by the sector. This can always be determined by the central angle created by the two radii. So basically the formula to find the arc length is whatever that angle is over 360 times 2 pi r, because that's my circumference formula. And the formula for area of a sector is the same thing. Whatever that central angle is over 360 times pi r squared. So these are the two formulas that we're going to be using. And we're going to use those. We'll try them out on the next page. All right, so a patio in the shape of a circular sector has a radius of 20 feet and a central angle of 110 as shown. Find the area of the sector to the nearest square foot. So it's the angle, 110, over 360 times pi r squared. So the angle over 360 times pi, and my radius is 20. Okay, so I can do that right in my calculator. 110 divided by 360 times pi times 20 squared. So try that in your calculator. Make sure that you're comfortable putting all that in. I get 383.97, and they want this to the nearest square foot, meaning I do not want any decimals. So 384 feet squared. Okay, so that's basically it. A garden has the shape of a circular sector that is straight sides measuring 50 feet and a central angle is 132. The garden needs to be surrounded by fencing. How many feet of it are needed? So I need to find the length of this arc. So I'm going to use my circumference formula, okay, which is 2 pi r. But I don't want the circumference of the whole thing. I'm going to multiply that by the portion of the circle. That's the angle 132 over 360. Okay, so 132 over 360 times 2 times pi times 50. Okay, so all of that is going to give me the length of that arc that I have in green. But then I also need to remember I'm finding the perimeter of this whole thing. So after I do that, I'm going to have to add on 50 and 50 for the sides. So all of that goes into my calculator. Because really this garden has 3 sides. No, they're not really sides, but I got the 2 sides and I have the arc. So it's the arc plus the 50 plus the 50. The arc is what I have in green. Okay, so in your calculator, 132 divided by 360 times 2 times pi times 50. Now, I did that separately, so if you want to do that separately, you can, but you don't have to. I get 115.1917, but then you have to add on the 50 and the 50, which is really just adding on 100. So that's 215.1917, and I want that to the nearest foot, meaning I don't want any decimals, so I need 215 feet of fence. Okay? So, the last kind of problem that I want to try is, well, what if I give you the area of the sector and you have to work backwards and find the radius, okay? So a sector of a circle, well, in this case I have the radius, sorry. A sector of a circle whose radius is 5 has an area of 20 square centimeters. What is the central angle of, is the central angle of this sector acute or obtuse? So remember, the area of a sector equals the angle over 360 times pi r squared. In this particular case, you know the area of the sector. You don't know the angle. And you know the radius. The radius is 5. So sometimes they might have you find the radius. Sometimes they might have you find the angle. In this particular case, I am finding the angle. So 5 squared is 25. So I got 25 pi on that side. So I got 20 equals x over 360 times 25 pi. All right, so I'm dividing by 25 pi because I'm trying to solve for x. So let's get rid of this by dividing by 25 pi. So if you do 20 divided by 25 pi, okay, so I'm doing that in my calculator, 20 divided by 25 pi, That gives me 0.254647 equals the angle over 360. We'll just put a 1 under that and cross multiply. 1 times x is x. So I'm taking that 0.254647. That should still be in your calculator. So you don't need to retype it in. And you're multiplying it by 360. And I get 91.67. So the question wants to know if this is acute or obtuse, and the answer is it is an obtuse angle. So all you're doing on these is you're substituting in the radius and the area, and you're solving for the angle. Sometimes you might be substituting in the angle and the area and solving for the radius. So let's look at this very last problem. A horse attached to an 8-foot long rope can rotate through a distance of 28 feet. What angle can the horse walk about? So this is not talking about area, but the length of the sector. And remember, the length of the sector is the angle over 360 times my circumference formula, so times 2 pi r. I know the length of the sector, it's 28. I don't know the angle. I do know the radius is 8. So 8 times 2 pi is 16 pi. I'm going to divide by 16 pi because I'm trying to solve for x. So 28 divided by 16 pi, that's going in your calculator. Now, when you do this, you really need parentheses around here. Whenever you have a fraction, there are implied parentheses that are going on. Okay, so 28 divided by parentheses 16 pi. And when you do that, so make sure you're trying this out so you're getting this right. 0.55704 equals x over 360. And then I just put a 1 under there and cross multiply. So 1 times x is x. 0.55704 times 360 is 200.5. So I want that angle to the nearest degree, and it's 201 degrees. All right, so we'll be practicing all of that tomorrow.